Today's lesson is talking about a quadratic function when it's written in standard form. And our main goal here is going to be to graph it. Okay, so standard form looks a little different than vertex form. It looks very pretty, that's why it's called standard form. We have to do a little bit of work to graph it. So some key features that we can figure out when we look at standard form. The first one is the y-intercept is the c. And we can find the vertex by using this formula, negative b over 2a. That gets us the x value of the vertex, and then we plug that back in to get the y value. Okay, so I'm going to show you how to do that by this example. So graph f of x equals 2x squared plus 4x plus 3. All right, the first thing I'm going to do is find the vertex, and that's step number 1. So to find the vertex, I'm going to use negative b over 2a. You guys can see that, yeah. Okay, and so remember, this is A, this is B, and this is C, all right? So negative 4 over 2 times A. Negative 4 over 4, so negative 1. So the vertex is negative 1, that's the x value, and so then I have to plug negative 1 back into this equation to figure out the y value, all right? So a lot of times what I'll do for that is I'll kind of do it right over the problem. I almost wish I didn't write that a, b, and c there. Okay, so negative 1 squared is 1. 1 times 2 is 2. So I'm going to jot down a little 2 here. Negative 1 times 4 is minus 4, and then I have this plus 3. 2 minus 4 is negative 2. Negative 2 plus 3 is 1. So my vertex is negative 1, 1. I also know by looking here that it's going to be a smiley face, so my picture should go up like that. Okay. So that is the vertex. I have plotted the vertex. The next thing is the y-intercept. The y-intercept is right over here. The y-intercept is 3. Now, that's really easy to see in standard form. And then I can use the axis of symmetry, which is right here. I can use the axis of symmetry to flip it over, and I know it's going to be over here. Now, I really do like to plot another point. So since I have on the x value, I have a negative 1 value, I have a 0 value, I'm going to go ahead and plug in a 1. So when I'm going to try to find another point, which we're all the way to step 4, where I plugged in a 1 value. All right, and once again, I kind of have to do it up here. This is a positive 1. 1 squared is 1. 1 times 2 is 2. 1 times 4 is 4. I have a 3. Let's add those together. 4, 5, 6, 7, 8, 9. So 1, 9. And then I can just reflect it on the other side. So there's my parabola. All right, we're going to practice this a little bit more. Actually, what I wanted to do is just basically use these to get some answers, and then you could graph from there. So the first thing, it says find the y-intercept. So what would the y-intercept be in this equation? Let's drop down little notes here. My y-intercept is 4. It's just that guy on the end. All right, my vertex. Okay, remember my vertex, I have to calculate it. It is negative b over 2a, all right? So negative b, negative 2 over 2 times a. I don't have a value there, so it's just a 1. So negative 2 over 2, which is negative 1, right? So my vertex is going to be negative 1, and now I have to plug in my negative 1 into this equation, all right? Negative 1 squared is 1. Negative 1 times 2 is negative 2, plus 4. 1 minus 2 is negative 1. Negative 1 plus 4 is 3. All right, the axis of symmetry. The axis of symmetry is always the x value. And that's about it. All right, so let's do the same thing with this one over here. And this one looks a little messier. My g of x, I noticed I have some decimals. I have a negative in the front. Seems like a little bit of a headache. Let's see how it's gonna go. Okay, my y-intercept is -4. My axis of, my vertex. Once again, I have to use my equation. I can't just look at it like when it was in vertex form. -b over 2a, -b, so that's -3 over 2 times -0.75. Okay, so I have -3 over -1.5. which is going to be a +2. Now I have to plug that in. I have to plug that in, that 2 into here. So I'm going to do 2 squared times 0.75 negative. Okay, and that gets me -3. So up here I have a -3. I'm going to plug my 2 in here. 6 minus 4. -3 plus 6 is 3. 3 minus 4. 3 minus 4 is -1. All right, so that's my vertex. My axis of symmetry is x equals 2. All right, so a lot of times we'll have some real life word problems, and you know, just think of what shape a parabola makes, right? A parabola looks like, you know, a lot of times we're going to see word problems where we're going to see this: a ball is being kicked, or a ball is being kicked and it goes in the air and then it lands, or I throw something out the window and it lands, and that would, you know, be the other side of the parabola. So a lot of this shape is going to go on with word problems. So this word problem right here says that we have a water fountain, and we have 2 water fountains. We have water fountain A and water fountain B, and they give us the equation for water fountain A, and this is like the, you know, the trajectory of the water. All right, and this is water fountain B, and they want us to compare each vertex and find out which one gets to a higher point. Okay, well, let's start off with water fountain B, just because that's a little bit easier. If I can see, right, it's the water fountain is going from 5 to 8. So this is the height. It's getting higher and higher and higher. And then at 10, it peaks out at 10. It starts going lower and lower and lower. So I can see that this right here is my vertex without doing a whole lot of work. Now for this guy over here, I have to find my vertex. I have to use -b over 2a, -2 over 2 times, that's a -1. So -2 over -2, which is 1, all right? Plug 1 in. 1 squared is 1 times negative is -1. 2 times 1 is 2 plus 8. 8 plus 2 is 10. We have a 9 here. All right, so this is going to be the height of it. So if this is the vertex, right, this is at 1, it gets all the way to 9. So this is going to be how high it goes. So we can see by comparing the vertexes that which trajectory reaches a greater height. It is B. Okay, that one reaches higher. That one goes all the way to 10, and this one only goes to 9. All right, Mia tosses a ball to her dog. The function, they give you the function. Oh, this function's in vertex form. That's weird. We're talking about standard form. What does vertex form tell us? Okay, so just a little refresher. Remembering, if we look at vertex form, we can see some things. We can see the vertex pretty easily. We can tell that it's shaped this way, where it's going down. And it's going to be wider than a normal parent function. Okay? All right. So we can say it's going to be wider, and it's going to be opening down. All right, we want to rewrite this in standard form. So I'm going to do this over here. Ooh, rewrite this in standard form. Okay, so standard form, basically I want to get rid of this parentheses. Okay, so let's see, how could we do this? Let's start off. I'm just going to give it a shot one way. There might be an easier way to do this. Okay, remember, I can't just distribute this 2 here. I have to write this twice and FOIL it out, or there was a shortcut if you're that person that remembered that shortcut that we went through. Okay, x times x is x squared, minus 2x plus 4 plus 8. Okay, I'm going to combine these like terms in here. X squared minus 4x plus 4 plus 8. I have to distribute this 0.5. Okay, that turns to a positive. Half of 4 is 2. Half of 4 is 2. Okay, and I have to combine these. So that is the function in standard form. All right, I kind of rattled through that pretty fast. I took this, I wrote it twice. Now remember, if you remember the shortcut, you can go from here straight to here. Then I had to distribute this 0.5 and then combine my like terms. Okay? Now I kind of think vertex form is a little more helpful, but standard form, a lot of times, answers are going to be asked for to be written in standard form for your final answer. So it is important that you know how to go back and forth. All right, have a good day.